Today we're going to talk about 10.6, solving exponential equations. Now, in order to do this, we're going to come up with a pretty important property or rule or whatever you want to call it. It's called the change of base formula, if you will. And it says, for all positive numbers, a and n, where a does not equal 1, this is true. Log base a of n equals log base 10 of n over log base 10 of a, which is also just log of n over log of a. Now that's really important because, as you know, your calculator only does, or I should say the majority of your calculators only do log base 10. And so now with this little rule here that we have, we're able to now solve all different types of logs. So for instance, like number 1 here, if I see log base 5 of 4, according to the change of base, that means I could rewrite this as log of 4 divided by log of 5. And then I'd take my calculator, and I would simply do log of 4 divided by log of 5. And I get, if we go, let's go hundredths place, I get about 0.86. And that's it. That's as difficult as it comes. Okay, now one thing that I want to talk to us about is something that's called calculator ready form. Calculator ready form. And what that is you simplifying whatever problem we're looking at down until we get to the point where you now have to use your calculator. So for instance, this right here would be considered calculator ready form. Sometimes we just abbreviate CRF. Okay, calculator ready form. Okay, so for instance, on this second one here, log base 4 of 48. If I'm going to put this in calculator ready form, I'd do log of 48 divided by log of 4. And then to actually get the answer, I would just take my calculator and I would do log 48 divided by log 4. And I get about, if we go hundredths place again, 2.79. That's it. Okay, that's not terribly difficult. Now, that helps us solving exponential equations, like these that I have here. So for instance, this one, this says 5 to what power equals 35? Well, I mean, you could take a great guess. We know it's probably going to be between, what, 2 and 3. The question is where? So what I would do is I would change this to log form. So I'd write log base 5 of 35 equals x. Okay, I would do change of base, log of 35 divided by log of 5. So that's my calculator ready form right there, calculator ready form. Answer, take log 35 divided by log of 5, and I get right there, if we go hundredths place, 2.21. 2.21. For those of us who forget, and I've done this a couple times now, this little squiggly looking equal sign means approximately. Okay, that's a way to indicate people saying, I know that's not exactly the answer, but it's pretty close. Okay, let's try this one. Let's try this next one. 4 to the x minus 2 equals 5.1. Great time here for you to hit pause, see if you can do it on your own before I do it. Alright, so what I would do is this. I would change it to log form. You probably guessed that. Log base 4 of 5.1 equals x minus 2. I would do change of base right here. Log of 5.1 over log of 4. Now what I would do, because what you want to do every time is put it in calculator ready form every single time. So what that means is I'm going to have to add my 2 to the other side. So I get log of 5.1 divided by log of 4 plus 2 equals x. So this is in calculator ready form. So now it's time to break out the calculator, and let's go through and do that. So I'm going to do log of 5.1 divided by log of 4, and then I'm going to add 2. So what is my actual answer? My actual answer is x equals hundredths place 3.18. Okay, it's approximately 3.18. Okay, there we go. And that's something that I'll ask on a test or even a quiz, where I'll say, give me the calculator ready form and give me the answer. So you need to be able to produce both of these things. Okay, let's move on down to another one. All right, let's look at this one. I'll be honest, I have no idea why I have 2 3s here. Sorry about that. Now, these are a little different here. Kind of think to yourself, what could I do? A little different, obviously, than these, because you notice here both we have exponents. Also, I can't change these bases to be the same. So we can't do that little trick of getting the same bases and setting the exponents equal to each other. But what I can do is this. I could go through and take the log of both sides. So I'm going to log 5 to the 3x, log this side too. Okay, so that's no different than squaring both sides, adding 5 to both sides. Now, that might not seem like that's real helpful to you, but what I can do now is power property. Bring that out front and this out front. We get 3x log 5 equals 2x plus 1. Notice this in parentheses. Log 12. All right, now what? Well, what's going to be next is this. Notice here that there's this quantity right here. So what I can actually do is I can actually distribute this in. So I'm going to get 3x log 5 equals 2x log 12 plus 1 log 12. Don't really need the 1, but I figured I'd put it there. Now what? Well, just like with any other equation you've ever done, what was kind of the golden rule? Well, the golden rule is to get the x by itself. So let's do that. Let's move this to the other side. So I'll do that. 3x log 5 equals, whoops, not equals, minus 2x log 12 equals log 12. Well, what do you notice that these have in common? They both have an x. So I can factor that out. X 3 log 5 minus 2 log 12 equals log 12. Really close to being done. Next step, well, we got to get the x by itself. So how do I do that? Well, it's x times this, so I'm going to divide by all this stuff on both sides. And over here it goes away. And here I get x equals all this stuff. And guess what? This is calculator ready form. Okay, then it's your job to go through and type that in. Now, I'm not going to show you how to do that. I'm going to have you give that a shot, but what I will tell you is the answer. And the answer should come out to be somewhere close to negative 17.56. Okay, so that's your job to go through and try and get that answer. So hopefully you typing it in correctly it'll come out to be that. Okay? So, here is your task. Your task is to try number 4. Number 4 is not much different than number 3. Try that, see if you can come up with the correct answer. All right, give you a hit pause and give it a shot. All right, here we go. Let's see if we can, I'm going to put a little line right here, kind of keep it separate. So, first step, I'm going to log both sides. Log 2 to the 2x equals log 3 to the x plus 1. What I do next, I did the power property. So I'm going to do 2x log 2 equals quantity of x plus 1 log 3. I'm going to distribute that in. 2x log 2 equals x log 3 plus log 3. Move all the x's to one side. I'm going to get 2x log 2 minus x log 3 equals log 3. Factor, I'm going to take out the x. Log 2 minus log 3 equals log 3. And then whoops, forgot my parentheses right there. Get the x by itself, so we're going to do a little division. Alright, so calculator ready form should be this. So that's my calculator ready form. And to keep you in suspense, oops, sorry, didn't mean to go off the paper right there. So to keep you in suspense, I'm not going to tell you the answer. We will talk about that in class, so give it a shot, see if you can come up with the right answer. I'll give you a hint, it'll be a decimal. Alright, see you in class.